Hello people, I'm Stone Moon from Chinese Academy of Science. I'm here to introduce you a truck dispatching simulation environment called OpenMines. It's completely open source, built just for a problem with many handy tools. When we mention the OpenMines truck dispatch algorithm, we can face a lot of problems. Like there's no pre-existing open source project. If you search this on Google or GitHub, there will be empty. Okay, and I've read a lot of academic papers researching this area. There's a huge problem that it is very difficult to reproduce their algorithms because they are mostly closed sourced. And also the environment is mostly static. There's no random event in the simulation. I have visited some real open pit mines. I've been staying on the mines for like weeks. There are many random events, like the truck can break down and need to repair, and the shovel is not sustainable as well, and the road has problems. All those randomness is very important and crucial for the performance. So that's why I developed OpenMines, a completely open source project built for the truck dispatching algorithm. To use OpenMines, you need to first write a config file to describe your problem. And then you can place this config file anywhere you want. You can see here is a baseline dispatchers. If you write a new dispatcher, just add the string to the list. And also there is a charging site where all the trucks start from time 0. And there are also different types of trucks. You can alter those parameters and names, whatever you want. And there are also many load side and dump sides. It also supports different kind of shovels. The second thing you need to do is to write your dispatch algorithm in the format that OpenMines can read. There are 3 types of dispatch orders: init order, haul order, and back order. You just need to assign your order to each truck. So when the simulation starts, the truck object will call for a dispatch, and that's an init order. When it arrives the loading site, okay, it will ask for the target dump site, and that's a give haul order function. And when it finishes dumping in the dumping site, then it will ask you for a load site, and that's a give back order function. You can insert the blank with reinforcement learning, operations research, and many more. Just use your imagination. So when you finish the previous steps, all you need to do is just to run the simulation. And here, let's assume that the North Pit mine config is already here. Then you run this F command. Then the OpenMine will run the simulation for you and have a very nicely table. Okay, you can see here is a produced tones, decision latency, famous match factor, wait time, road jams, truck trips, and even jam ratio. The probability that your truck will face a jam event. And the OpenMines also provide you with a very handy visualization tool. Let's say that you've just finished the F command. Now you have a result folder. All right, a result folder. Inside the result folder, there are many JSON file concerned with dispatcher. All you need to do is just to visualize. Use the v command of your dispatcher. then it will generate a GIF. Well, it takes some time, surely. And you can see to the left, here is a visualization of the nearest neighbor dispatcher. And you can see it dispatch every truck to the closest load site. All right, then it will go to the closest dump site. After loading the closest dump site, it will visit the closest load site to this dump site until the end of the dispatch. And also you can see there are many red dots here. The red dot means the jam event. If a jam event happens, every truck goes over will be slowed down. And the blue dots represents the fixed event. Like your truck has a problem, the driver has to rest or whatever. Okay, it slows down. The shovel will be unfunctional if random event happens. To better find out the problem of your dispatcher, there is also a function called the log analyzer, driven by the large language model. You can use this function by tapping the command like this. Then it will generate a report in the format of Markdown. Describe how well your dispatcher is performing and where the problem probably is. It usually takes minutes to describe your problem. Because this log might be extremely large, bigger than the context of the large language model. So usually, the log dispatcher will chop the log file into 3 pieces, review them individually, and then combine them, then analyze. Okay, another very promising direction is called reinforcement learning. It's also supported by OpenMines. All you need to do is just to import the OpenMines gem package. Here is a minimal example of how you train a dispatcher with reinforcement learning on a target mine. It also gives suggestions inside the info. You can use this info suggest action to guide your policy. If you are interested in the details, you can visit the link to your right. So there are 2 types of reward functions. There are 2 types of reward functions. One is called the dense reward, another called sparse reward. I have done detailed research on them in my paper below. And the dense reward is generally better than the sparse ones, especially when we use some guiding technique. If you want to customize the reward function, you can visit this function called get reward dense, then modify the logic. If you want to use some parallel training, you just need to wrap the environment with this object inside the Gymnasium, so you can parallel training. Okay. I also have a example train code inside this pass. This is exactly the same code in my paper. If you literally are a mine, you might be very interested in the scaleness of your algorithm. It's also supported in OpenMines. All you need to do is to run the following command below. Then you can have 2 graphs describing the scaleness of your algorithm. To your left, we compared the different baseline algorithms on the same mine. you can see the RL trend on the fixed fleet size has a very good scaleness. And to the right, you can see there is two different kind of algorithm compared on 3 different scenarios. You can also view the scaleness of your dispatcher, but on a different scenario. So I really do hope that OpenMines is a brick that helps people to enjoy the free, accessible, high-performant truck dispatch algorithms. And I have visited some CTO of truck company, OpenPitMine company. They like it. So if you're interested in cooperation, please contact me with an email. And if you have any problem with the code, you can submit an issue in GitHub. And if you want to communicate with people, we can use the Discord. If you want to cite, well, here is a reference material. You can just cite it. It's already published paper. Okay. Goodbye.